So my name's Liz Rice. I work for a company called Aqua Security, where we focus on securing container and serverless deployments. I run our open source engineering there. Pretty recently I got made an AWS container hero, so that's very exciting and makes me feel like I must be in the right place here, right? So today I want to talk about container vulnerability scanning, or more particularly, container image vulnerability scanning. Can you put your hand up if you are using containers? Excellent. Can you put your hand up if you are scanning your containers right now? Okay, there are a few of you. Everybody who had your hands up before, next time I see you, you have to be scanning your containers as well, right? So, what we're going to talk about this afternoon is what are these vulnerabilities that I'm talking about, how we find them, basically how scanners work, and what you can do to protect your containers from vulnerabilities. When I talk about vulnerabilities, I'm talking about weaknesses that an attacker can take advantage of. Something that an attacker can use, typically a flaw in the software that an attacker can use to get a foothold in your deployment. Some of these kind of vulnerabilities you'll have heard of. Anybody want to shout out if you know? I mean, two of them have their names, so you can guess those, right? The other two, do you want to shout out what they are? Sounds like it. So the shell shock, heartbleed, obviously meltdown and dirty cow. Those are like kind of rock star vulnerabilities that you've all heard of. They are very much the tip of the iceberg. There are thousands of software vulnerabilities that get discovered every year. They're not all as serious as this, but some of them are, important nonetheless. When a researcher finds one of these vulnerabilities, they get an identifier called a CVE, which stands for Common Vulnerabilities and Exposures. And we use these CVE identifiers to label each of these different vulnerabilities. Those vulnerabilities get listed in this thing called the National Vulnerability Database. Obviously, it's an American thing, so the fact that it's national, it's actually kind of used internationally. And this has a list of all of the disclosed CVEs, and it maps them to the libraries, the packages that contain those vulnerabilities. So in this example, here's the information about Heartbleed as it's shown in NVD, where it basically says, this might be a little bit small to read, but it's basically saying Heartbleed was in OpenSSL, the OpenSSL package, in all the versions from 1.0.1 through to 1.0.2.beta 1. So if you had any of those versions of that library in your deployment, you would be susceptible to the Heartbleed vulnerability. A vulnerability scanner is something that looks at software and identifies whether or not it's got vulnerabilities in it. And today I'm particularly interested in talking about scanning container images. We can only really scan for known vulnerabilities. Vulnerabilities that have been discovered by a security researcher, and the researcher has been able to assess which versions of which package are affected by that vulnerability. A scanner can't find vulnerability, or at least this kind of scanner can't find vulnerabilities that aren't kind of known about. So first of all, we're not talking about vulnerabilities in your own application code. You can very, very easily write insecure code. A container image scanner isn't going to find that for you. The other thing it won't find is what we call non-disclosure. So there is a period between when a researcher finds a vulnerability, and if they're a responsible researcher, they will talk to the the vendor or the developer of that piece of software, and they'll say, hey, I found this problem. You may have seen in a lot of open source repositories will have some kind of email address that you're supposed to disclose security concerns to. And the idea is that in private, the researcher and the developer will kind of collaborate on making sure a fix is available. And there's typically a period, they will typically agree a period of time for the developer to come up with a fix before the researcher publishes information about the vulnerability. And during that non-disclosure period, the idea is that, the researcher isn't telling the world of attackers, here is a vulnerability you can exploit. The idea is to publish the fix and the vulnerability at the same time. So a scanner is only going to find published vulnerabilities with a CVE assigned and where the information is available in NVD. And the scanner, as we're going to see, will identify whether or not your code is using these components with known vulnerabilities. And there are several options out there. I'm going to talk about an open source tool from Aqua that's called Trivy. There's another open source tool called Claire. There are several commercial options out there as well. What these all have in common is they're looking for the known vulnerabilities. They're not looking for unknown vulnerabilities. There are tools that can help you with that by doing things like fuzzing and penetration testing. That's not what I'm talking about. I'm just talking about finding these heartbleeds and shell shocks and their cousins. So if you have a container image, it's probably stored in a registry somewhere. You pull the image out of the registry, and you deploy it into your ECS cluster or your EKS cluster or what have you. Some number of instances of that container will be based on that container image. So if your image has a vulnerability in it, all of the containers that are instantiated from that image will be affected. So we scan the image and ideally use that to stop containers from being deployed from an image if it turns out to have significant vulnerabilities in it. And you may also need a way of identifying which of your running containers were based on an image that you just discovered is like really dangerous and you don't want to be running it. And ideally, you want to automate this kind of scanning in some kind of CI/CD pipeline so that you can automatically prevent images from being deployed if it turns out they have some significant issue. So really what vulnerability scanners are doing is looking at the contents of a container image, identifying which packages and what versions of each package are contained in that image, looking them up in the vulnerability database and telling you if there are any known vulnerabilities associated with those packages. And that sounds really easy, right? So it's not quite as easy as that, and we'll see why that is in a little while. But before I show you why it's a little bit more complicated than that, I want to show you a little bit about Trivy, and in particular, Trivy being used, I've got a demo basically. So Trivy is super easy to run. You just run Trivy and your image. But as I already discussed, you probably want to have it in a pipeline. So something like Travis or Circle CI or indeed AWS code pipeline. And it should just be a case of adding the Trivy command into your script somewhere. So if the network gods are with me, we'll be able to see this in action. So I have a code pipeline job set up, and it's running this build spec. Now, I'm doing something here that I actually think is terrible, but this is just a demo, right? I'm starting with a build environment. That build environment is actually a container, and then I'm installing Trivy. I don't know if you can see my highlight. I'm installing software into that container image, which is terrible. You should always treat your containers as immutable, never install image into a running container. But you're just going to have to forgive me for that today. For the purposes of the demo, I'm starting with one of the default Amazon build environments, and I'm installing Trivy into it. And I'm also going to check that I can log into ECR. And then when it comes to the actual build, what it's going to do is build the contents of a Docker file, which I'll show you in a second. Once it's built it, it's going to use Trivy to scan it. And if that is successful, it's going to push the image into ECR. The parameters I'm using here are basically saying, if you find a high severity or critical severity issue, then exit with exit code 1. That will cause the build to fail, or at least this step to fail, and it wouldn't go on to doing the push. My Docker file is super easy. All I'm doing is basing it on a version of Alpine, an existing Alpine image. So here is the build pipeline, and a few minutes ago I built this. I've already loaded this up into another screen because network. And what you can see here is it failed. I ran this 2:30 today. And you can see it going through these phases of installing Trivy, lots and lots of really boring logs, downloading some data. Where do we do that? No, here we go. Right. So here we do the Docker build. You can see the Docker build is going to start there. Pulls down Alpine 3.10.0. Here we're running Trivy. And Trivy found a high severity issue. And because of that, it failed the build. Now, that was using Alpine 3.10.0. There is a newer version which rectifies that particular vulnerability. So I'm going to update my Docker file and just commit this, so use Alpine 3.10.2. Hopefully this will push without too much trauma over the network. And maybe, maybe not. There we go. Have I typed in my passphrase correctly? Eventually. Come on, network. It's like doing it by semaphore in here, I think. I'm hoping that that is going to push the updated version of this Docker file. The fact that I've made a code change in the code commit repo, hey, should trigger a new run of this build. So let's see if we dare try refreshing this page. Hopefully this is going to show us that a new build will have been triggered eventually when it's sent all the details by Morse code or whatever it's doing right now. Maybe we'll come back to this in a little while. I do have a screenshot if all else fails. But hopefully that is triggering a new run of that build, but using a newer version of Alpine. So we should be scanning a newer version of Alpine. All right, while that's going on, let's talk about why scanning isn't just as simple as looking up entries in that national vulnerability database. And in order to understand that, we need to talk a little bit about Linux and distributions of Linux. So there is a Linux kernel. The Linux kernel is essentially one thing. There are different releases of it, different versions of it, but basically every Linux you use uses the Linux kernel. But there are lots of different distributions of Linux, and you'll probably have heard of many of these different distributions. And if you're using containers, your containers could be based on any distribution of Linux. Those distributions have differences. Things like they might have a different shell by default. They might or might not include a GUI. And importantly for our purposes, they might have different package managers. So I don't propose to go through this slide, but this is just to give an example of how different distributions give you different tools, different editors, and different package managers. And it's package managers that we typically use to install these packages that are listed on the NVD and in which known vulnerabilities may or may not exist. And scanners will typically use the package manager as a way of figuring out, as the tool to figure out what packages are contained within a particular image. So your containers and your container images could have, some of them could be based on Alpine, and some of them could be based on CentOS, and some of them could be based on Ubuntu. Inside your container image, they might be based on Scratch and not have a Linux distribution at all, but the majority of container images today do include some Linuxiness. And so inside your container image, it looks like a Linux machine, and it looks like there might be packages that have been installed by a package manager. When we talk about these packages in a Linux distribution, the package contents will also vary from distribution to distribution. So some developer somewhere writes some code, some software, and they might build it and package it and distribute it as a binary distribution. You often see this on GitHub repos. There might be releases that you can download. Here are the different binaries for your different chip architectures and what have you. But a lot of the time, rather than downloading those binaries directly, we use a package manager like apt or yum, and that is taking the distribution packaged version of the software. So not exactly what the developers built. Each distribution might decide to kind of recompile from source. They might choose to enable certain features or disable certain features. They might choose to link with certain libraries or statically, or leave them to be linked dynamically. And importantly, from a security perspective, they might decide to apply security patches. They might decide to fix some bugs that the upstream developers haven't actually fixed yet. Entirely up to whoever's maintaining the distribution and how they want to deal with that. So each distribution in its package repository, in its set of packages, might have a slightly different version of the software. And if the software is different, it might have different vulnerabilities in it. If we take Debian Ubuntu as an example, the maintainers of Debian have a very strong focus on stability. They want to know that the software that you use, they probably do 2 releases a year or something, and the packages have a similar lifetime. Now, security vulnerabilities get found all the time, and you can't wait for a whole release of, you can't wait 6 months for Debian to release a whole new image, a whole new version of their distribution to get a security update. You need a security fix as soon as possible. But the approach that Debian take is to say, well, I don't want to take a whole new release of that software. I'm just going to cherry pick the security fix that I need and apply that to the current version that I have in my distribution. So it's backporting these fixes to whatever is currently the kind of approved version for that supported release. So as an example, this is just a kind of random vulnerability that I found. This particular vulnerability existed in a cache called Varnish between version 4 and 5.2. That's what NVD knows about. So anything between 4.0 and 5.2 was affected by this vulnerability. This is an extract from the Debian Security Advisory about this particular vulnerability. And I don't know if you can see here, if you had this stretch distribution, they're using 5.0. So in theory, that is affected by that vulnerability. In practice, Debian applied a patch. So the NVD, if you only looked at the NVD data, you would think this is vulnerable because it's one of the versions that NVD said was vulnerable. You have to have knowledge of this security advisory from Debian to figure out that, actually, no, it's okay. So long as you've got this patch, you're good. You don't have that vulnerability. So your vulnerability scanner has to be looking at the security advisories from whatever distribution you're using. Here's another example of how Alpine manage their security fixes. So if you looked at BusyBox, this particular version of BusyBox 1.27.2, it had 3 significant vulnerabilities in it. The version that Alpine were distributing at the point where I took this screenshot, they have actually patched those 3 vulnerabilities. They still call it BusyBox 1.27.2, so you had to look at this kind of build information to find this patch to know that it's been fixed, or that these 3 things have been fixed. And then there's also this 12 other changes that, they're probably great. They're probably amazing fixes that the Alpine developers have put in there, but you don't really know. From a security perspective, those are a bit of an unknown. There might be other security issues in those patches. Not really any great way of knowing unless there's a security advisory from Alpine about those patches. The last thing that I wanted to sort of talk about in terms of how these vulnerability scanners work is thinking about the types of software that they're scanning. So far I've been talking about system packages, the kind of things that get installed with things like apt or yum. There are also language-specific application packages. So for example, npm for Node or pip for Python. And the languages also have security advisory information. So some scanners will have some information about these kind of language-specific vulnerabilities, because they can and often do have very significant vulnerabilities in them. The last sort of way that software tends to get into container images or tends to get onto machines is by running commands like wget or curl or make. And then you're not getting the software from a package manager of any description, and scanners typically will not be able to identify the problems, any software installed in this way, because they're typically looking at the information from the package managers. Okay, so because of the differences in sources, because of the differences in distributions, your scanner will be more accurate if it pulls information from more of these different information sources. I think all scanners start with the NVD, but they may have a different set of security advisories that they pull from different distributions. Some software vendors also have their own security advisories for particular pieces of software. And application package managers, does your scanner support the language that you're using? There are also commercial databases that have additional information about security advisories, particularly this is more around sort of malware particularly, but if your scanner uses, the more data sources it uses, the more likely it is to be accurate. There are also differences in the way that scanners look at container images in terms of looking at layers or looking at the image as a whole. I'll try and touch on that in a few minutes. And there are different techniques for detecting which versions are actually installed. Version comparison is usually the best way of doing it. So, scanners have different functionality. They may also be doing other things as well as scanning for package vulnerabilities. They might also scan for things like sensitive data in files. They might support Windows as well as Linux. I gather there is an operating system called Windows. That's pretty much everything I know about that. But scanners can also be looking for things like malware fingerprints. You'd be unlikely to find that in a free or open source scanner because the malware fingerprinting is usually, the data is usually held commercially. Okay, so I think at this point I'm going to go back and see whether my build has finished. It still says it's in progress. At least it started. That's something. Let's see if I can open it up, see where it's got to. Yeah, that could take a little while to load, couldn't it? All right, I'll give that a second and come back to it. So with Trivy, it does have a pretty wide range of different sources. Very easy to install. It's open source, so it's free, which is nice, and it's very easy to use. Talk a little bit about how it works, because I think this is actually pretty cool. So there are these security advisory sources. And overnight, we run scripts that pull data from these security advisories. And they put that information into our vulnerability list. And that vulnerability list is held in GitHub. Open source, go and have a look at it if you want to. When you run the Trivy executable, the first time it will clone that whole vulnerability list. On subsequent runs, it will just pull the differences. So after the first run, it will be much, because it's a pretty large amount of data there, but it will become much more efficient after the first pull. So that's how Trivy's getting hold of the vulnerability data. You have your image that's in a registry, and Trivy will fetch the image. Maybe that's, Docker, could be ECR, could be whatever container registry. That's going to give you a set of tar files for each layer, and Trivy applies the layers to make sure it's only looking at the files that are actually present in your image when it's been kind of decompressed and applied. And it extracts the files, figures out using the package managers, which packages and what versions are installed, and then it can compare the image with the vulnerability data that it pulls and give you some output. Let's see whether we've got any output. We've got some output, woohoo! Right, and look, it's succeeded, amazing. So, we should see, you remember last time, in fact, I've probably got a copy of it. Here we'd found a high severity issue on Alpine 3.10.0, and here we scanned 3.10.2, didn't find any issues, which is awesome, and that meant it could carry on and push the repository into ECR. So if I go to ECR, there wasn't an image there before, and hopefully it will have, there we go, 306, we built our success tag issue. Hooray, live demo, and it worked, woohoo. So I hope that's shown you how it's pretty straightforward to build scanning into a pipeline like Code Pipeline on AWS. If you aren't scanning your container images, it's really easy to do it, and if you're not doing it, you could be vulnerable to exploits that you just don't know how vulnerable you are. And trust me, there are attackers out there who know they do know because they're trying, and they're trying to use these exploits. So whenever anybody says, what can I do to secure my deployment? Actually, scanning your container images is probably the most straightforward thing you can do, beyond like really obvious things like not giving out your password, things like that. But yeah, scanning your container images, hugely important. As a bonus, you can also use container image scanners, or there are some scanners will also support scanning Lambda functions as well. So vulnerabilities do exist in any software. That can include dependencies that Lambda functions may use. So that's kind of a topic for another day, but I just wanted to plant that seed of thought. If you want to try Trivy, it is, as I say, open source, available from aquasecurity/Trivy, and I will be publishing the build spec YAML, hopefully this afternoon. Right. With that, thank you.
Have we got any questions in the room?
Yeah, question.
So say I'm using a boot to Docker to host my containers or something like that, that has a Docker host. So how to actually scan the Docker host itself instead of containers, alongside containers?
Yeah. So I think the question is really about how do you scan the host on which your containers are running. That's actually something that has come up for us at Aqua quite a lot recently. And at one level, you can just think of it as, well, it's an image machine. It's a Linux machine. You know, it contains the same set of files. So you can just use the same scanner on that host set of images. So on the commercial product, we have started to slightly tweak our scanner to also address scanning the host as well as the images. It's essentially the same thing because you're looking at the packages that are installed on that host and looking for vulnerable versions.
Is Aqua aware of the changes that will happen after the scanning of the images? For example, when the container is running?
Do you mean...
how do you handle those?
Do you mean so...
Yeah, the image is scanned, the container is running now, and a change is happening there.
Right, okay, so there's two possible changes that I'm not quite sure which one you mean. One is new vulnerabilities are found, right? So, and this happens a lot, right? You have an image, you built it last week, but yesterday somebody found a new vulnerability in a package that you're using. The key to that is to just keep scanning on a regular basis. We recommend scanning all your images that are running every 24 hours and flagging up if you find, a new, or if you find an image that has a vulnerability in it, you need to get that rebuilt and redeployed. The other thing that can happen is what I showed you, and what I think is terrible, where I installed software into a container, kind of post deployment. It's a terrible idea to install software into a running container because it can't be scanned. So never do that, even though I just showed you it. Don't do it. All right. Any more questions? Oh, yes, one more.
Just on the mic.
Should you combine this with scanning your Docker host files as well?
Should you... Okay, I think that was the same question as the first one. Could you combine this with scanning your Docker host? So the host...
Your Docker host file that you used to build a container.
Oh, the Docker file. The Docker file, right. Yes. So there are some tools that will do, I'm just struggling to remember the name of it, but there is something that will look at a Docker file and do kind of hygiene on things like, are you going to run as root, or is your Docker file running as root? The thing that you can't do on a when you scan a Docker file is know which version of a package is going to be installed. So you quite often will see a Docker file that says run, I don't know, apt-get install library name, and it's just going to get the current latest version of that library. And it's only at the point where that's been run that you know what version that actually refers to at that time. So you can't just look at the Docker file and find that information. Obviously, if it specified a particular version, you could use that, but they typically don't. Oh, another question.
So we're starting to see a lot of image registries like coming with scanning built into them. You see that as a threat to tools like Trivy?
Okay, so the question is that lots of registries now have scanners built into them, and is that a threat to Trivy? I would say definitely not. So there are some hosted services will build registries into them, and some of those registries are people that we work with at Aqua. There are also some registries, so for example, the Harbour registry, which is a CNCF project, where right now it comes with Claire kind of built into it, but we're actually working very much in the final stages now of contributing some changes to make it pluggable. So you can choose whether you want to use Claire or Anchor or Trivy or whatever. I think the important thing is that people can use the scanner that gives them the best results for the platform that they're using, the distribution, the language, the support that they need. Okay. Well, I think that's probably the end of the questions. So thank you very much.
Thank you, Liz.